this video we're going to cover a Leetcode problem, unique paths. Major tech companies like Microsoft, Amazon, Uber are asking this problem during technical interviews. I hope you will find this tutorial useful for your technical interview preparation. Let's start with reading the question. A robot is located at the top left corner of MN grid. Robot is located here. Mark the start in the diagram below. The robot can only move either down or right at any point in time. So the robot can only move down or right. The robot is trying to reach the bottom right corner of the grid. The robot is trying to reach here. Mark the finish in the diagram below. How many possible unique paths are there? So we have an example here. It's an M3 and 2 grid and the output is 3. I can show you here. So this is the start position and this is the final goal position. What we need to do is if you go here, this is the first path. The second part is this one. And the third part is this. So we have 3 ways of reaching the goal. The idea is simple. When we go one step to the either right or down. Now we are here. We have 2 possible ways of going. We can either go right or down. And finally we have only one possible way to go, and that's the last one. In this case we have only one. And we have another option here. We can go down and right. When we calculate the numbers, basically we say we move, let's delete this. If I move one step, I write down the cost here. So it's one step. It's either coming from left or top, because we can only go either right or bottom. So in this case, for example, if I put it here, in this case it's either coming from top or left. So if this is one step and this is one step as well, this should be 2, because it can either come from top or left. And again, this could be 1, because there is no it can only go down. There's no right here. And the goal is basically the sum of these 2. It could either come from 2 or 1. So together it will be 3. And that's pretty much the idea. We check the top and left values and get the sum of them. So in this case the sum is 2. In this case the sum is 3. It could either come from this way or that way. So this is the basic idea. So how could we solve this problem? I want to talk about 2 different approaches here. One of them is dynamic programming, and the other one is recursive approach with memoization. Let's talk about memoization first, briefly. This is more complicated than dynamic programming, but I'll briefly mention this approach. For example, I'm here at start point I have two options. It's either 0, 1, I can go this way, or 1, 0, this way. If I'm at 0, 1, I have two options again. I can either go 0, 2, so let's do it this way, 0, 2, or 1, 1. Or then I can, from 0, 2, I can go to 1, 2, and 2, 2. In this case, from 1, 1, I can either go 1, 2, or 2, 1. So either this way or that way. And from there, 2, 2, 2, 2. So this is pretty much it. When we calculate it, we just like write down these numbers and also calculate the right hand side too. And in this tree, we use memoization to store these numbers store these values. So when we come across next time, we don't have to go through the same calculations again. That's pretty much the idea. But I don't want you to worry about this one that much, because dynamic programming is much simpler than recursive memoization approach. So let's talk about dynamic programming. In a simple grid, we have one step here and one step here. We can either we can either go this way or this way and this way. So there are two ways of going here. In this case, I come here, it's one step and one step in this one. If I go down, I have one step and one step again, because there's nothing coming from the left, there's nothing coming from the top. If you see the first row and first column, they're always one, because there's only one way to reach them. The second one is we can say 1 plus 0 is 1, 1 plus 0, because top is 0 here, 1. In this case as well, left is 0, 1 plus 0, 1, 1 plus 0, 1. This time 1 plus 1, 1 plus 1, 2. And 2 plus 1 is 3. 2 plus 1, 3 here. And we have 6 ways for this one. So we are dividing the problem into sub-problems and then creating the final using the sub-problems. So this one, this may take too much time, so I'll simply mention this one, then move on to coding. This is 1, this is another 1, this is 1, this is 2, and 1 and 2, 3. 3 ways, and we know those 3 ways. So we will use dynamic programming to calculate this 6 now, this final now. Okay, so in our solution we create one matrix for one DP array for the to keep the values, and we go through the matrix using 2 for loops for rows and columns. And when we hit the first rows, these first rows are always 1, always. When we hit the first row, if it's 0 and j is 0, then we turn them into ones. We mark them as ones. If we are in the other cells, then what we do is we use the up and left values. So I minus j, I minus 1, and j is upper value here, and I, j minus 1, is the left value. And that will give me current value here. So left plus up. That's what we're doing here. And when we mark all the cells, we can simply return the last cell. And this is our last cell here. I'll go over again. First we create our dynamic array, and we go through the m and n numbers, integers given in the question. Then we fill our dynamic array with DP array with the numbers. The first cells are always 1 because they are 1. And for the other cells, we simply calculate top and left values. We add them and we create the sum here and put that value in the cell. And that's what we do here. And finally, we return the very last cell, which is the final cell. Let's see if it's going to work. So for some reason it is slow. Sometimes it does this, yeah. So this is pretty much it, how we solve this unique paths problem. Using dynamic array, it's much simpler than the recursive version. So I hope this video helps, and I will solve other Leetcode problems in the other videos. So please subscribe to my channel, and hope to see you later.